Derive Avogadro's law. Derive Avogadro's law by using kinetic theory of gases. By using kinetic theory of gases. Derive Avogadro's law by using kinetic theory of gases. We can consider two gases. This is gas A and another gas vessel containing gas B, another gas vessel containing gas B, and we can denote the pressure, volume, temperature of the two gases. P1 is the pressure, V is the volume of gas A, T is the absolute temperature of gas A, T is the absolute temperature of gas A. Vrms1 is the RMS velocity of gas molecules. N1 is the number of molecules of gas A. Similarly for gas B, P2 is the pressure, V is the volume, T is the absolute temperature, Vrms2 is the RMS velocity of gas molecules, and N2 is the number of gas molecules. According to the kinetic theory of gases, the pressure exerted by the gas A, of volume V at the absolute temperature capital T, is given by P1 is equal 1 by 3 capital M by capital V, capital M1 by capital V, capital M1 by capital V, bracket closed, Vrms1 square, where M1 is the total mass of the gas A and Vrms1 is the RMS velocity of the gas molecules of gas A. P1 is equal to 1 by 3 M1 by V, Vrms1 square, where M1 is the total mass, capital M1 is the total mass of the gas A. Total mass of the gas A having N1 number of gas molecules. M1 is the total mass of the gas A having N1 number of gas molecules. Similarly, the pressure exerted by the gas B, of volume V, pressure exerted by the gas B of same volume V at the absolute temperature capital T, at the same temperature capital T, is given by P2 equal 1 by 3 M2 by V, bracket closed, Vrms2 square, where Vrms2 is the RMS velocity of gas molecules of the second gas B, where M2 is the total mass of the gas B. Containing N2 number of gas molecules. As the gases of equal volume under identical conditions of temperature, as the gases of equal volume under identical conditions of temperature, exert equal pressure, as the gases of equal volume under identical conditions of temperature exert equal pressure. That's why what we can say, P1 will be equal to P2. Pressure exerted by the gas A will be equal to the pressure exerted by the gas B. Therefore, 1 by 3 M1 by V, Vrms1 square will be equal to 1 by 3 will be equal to 1 by 3 m2 by v bracket close vrms 2 square. vrms 2 square. 1 by 3 m1 by v vrms 1 square is will be equal to 1 by 3 m2 by v vrms 2 square. By simplifying we get m1 v rms 1 square. m1 v rms 1 square will be equal to m2 v rms 2 square. m1 v rms 1 square will be equal to m2 v rms 2 square. In the diagram capital M1 is the total mass of the gas A. Capital M1 is the total mass of gas A. Total mass of gas A. Vrms1 is the RMS gas velocity. And in the second diagram, M2 is the total mass. M2 is the total mass of gas B. M2 is the total mass of gas B. Vrms1 is what? Vrms1 is the RMS velocity of molecules of gas A. Vrms1 is the RMS velocity of gas molecules of gas A. Similarly, and here Vrms1 is the RMS velocity of gas molecules of gas A. And in the second diagram, Vrms2 is the RMS velocity of gas molecules. RMS velocity, root mean square velocity of gas molecules of the second gas B. Vrms2 is the RMS velocity of gas molecules of gas B. In the diagram, at the absolute temperature capital T, average kinetic energy of translation per molecule. Average kinetic energy of translation per molecule will be K1 prime, and at the same temperature for the gas B, average kinetic energy of translation per molecule will be EK2 prime. Now the average kinetic energy of translation. The average kinetic energy of translation per molecule of the gas A at the absolute temperature capital T is given by EK1 prime is equal 3 by 2 kT. EK1 prime is equal to 3 by 2 kT, where K is the Boltzmann constant, though it is pronounced as K, but it is denoted by K subscript B. Similarly, the average kinetic energy of translation of one molecule or per molecule of the gas B, the average kinetic energy of translation per molecule of gas B at the same temperature capital T is given by EK2 prime will be equal to EK2 prime will be equal to 3 by 2 kT. EK2 prime will be equal to 3 by 2 kT. As the two gases are at the same absolute temperature, they will have the same average kinetic energy of translation. As the two gases are at the same temperature, they will have the same kinetic energy of translation. same kinetic energy of translation. Therefore, ek1 prime will be equal to ek2 prime. Therefore, or comma 1 by 2 small m1 vrms 1 square will be equal to 1 by 2 m2 vrms 2 square, where m1 and m2, small m1 and small m2 are the mass of each molecule of gas A and gas B respectively. M1 and M2 are the mass of each molecule of the gas A and gas B respectively. We get 1 by 2 m1 vrms 1 square will be equal to 1 by 2 small m2 vrms 2 square. That will be equation 2. Here, average kinetic energy of translation of gas A is ek1 prime will be equal to 1 by 2 m1 vrms 1 square, and similarly average kinetic energy of translation per molecule of gas B ek2 prime will be equal to 1 by 2 m2 vrms 2 square. Dividing equation 1 by the equation 2. Dividing the equation 1 by the equation 2. Capital M1 vrms 1 square. Capital M1 vrms 1 square divided by 1 by 2 small m1 vrms 1 square will be equal to capital M2 vrms 2 square. Capital M2 vrms 2 square divided by 1 by 2 small m1 vrms 2 square, or comma in the next line what we can write, or comma, by simplifying we get capital M1 by small m1 will be equal to capital M2 by small m2. Capital M2 by small m2, or comma, here on the right hand side what we can write, where total mass of gas A is capital M1 is equal n1 small m1 and total mass of gas B that is M2 equal n2 small m2, or comma capital N1 m1 by m1 will be equal to n2 m2 by m2, n2 m2 divided by small m2, or comma n1 will be equal to n2 will be equal to n2, where n1 is the total number of gas molecules of gas A and n2 is the total number of gas molecules of gas B. N1 and N2 are the total number of gas molecules. N1 and N2 are the total number of gas molecules of gas A and gas B respectively. So finally we get N1 will be equal to N2. Therefore, equal volumes of gas A, equal volumes of gas A and gas B, equal volumes of gas A and gas B under identical conditions of temperature, and pressure. Equal volumes of gas A and gas B under identical conditions of temperature and pressure, comma, contain the same number of gas molecules, comma, which is Avogadro's law. Equal volumes of gas A and gas B under identical conditions of temperature and pressure contain the same number of gas molecules, which is Avogadro's law. Hence, Avogadro's law is proved by using kinetic theory of gases. Hence, Avogadro's law is derived. Avogadro's law is derived by using the kinetic theory of gases. Now we can do the revision. Here. Pressure P1 is equal to 1 by 3 m1 by V. Vrms 1 square, and pressure exerted by the second gas P2 is equal to 1 by 3 m2 by V Vrms 2 square. Here pressure exerted by the two gases will be same. That's why P1 will be equal to P2 under identical conditions of temperature and volume. Therefore, as P1 is equal to P2, we can write M1 Vrms 1 square will be equal to M2 M Vrms 2 square. M1 Vrms 1 square will be equal to M2 Vrms 2 square. Now, second point, we have to memorize that EK1 prime equal to 3 by 2 kT and EK2 prime is equal to 3 by 2 kT. These are the average kinetic energy of translation per molecule of the gas at the absolute temperature. Under identical conditions of temperature, EK1 prime will be equal to EK2 prime. That means the two gases will have the same average kinetic energy of translation per molecule, and EK1 prime is equal to EK2 prime. And here, that's why what we can say, 1 by 2 small m1 Vrms 1 square will be equal to 1 by 2 small m2 Vrms 2 square. 1 by 2 small m1 Vrms 1 square will be equal to 1 by 2 small m2 Vrms 2 square, where small m1 is the mass of one molecule of gas A and small m2 is the mass of one molecule of the gas B. Dividing the above relation with the lower relation, we get capital M1 by small m1 will be equal to capital M2 by small m2. Therefore, N1 will be equal to N2. N1 will be equal to N2. That means the two gases will have the same number of gas molecules under identical conditions of temperature and pressure, provided the two gases will have the same volume. N1 is equal to N2, and this is Avogadro's law, and which is derived by using kinetic theory of gases